Hey everyone, today we're going to continue in section 3 and we're going to start on part 2 of measurement. If you recall in part 1 we talked about scientific notation, and today we're going to get a little bit more into what system of measurement do we actually use. So it starts off with the key question: what units do scientists use for their measurements? And to answer that, scientists use a set of measuring units called SI units. Now, SI comes from the French term, stands for International System of Units. It's actually the revised version of your metric system. So if you hear us say metric, it means the same thing as SI. It was originally developed in France in 1791. Most countries around the world actually use the metric system. America is one of those ones that use the imperial system, so we are not on board with everybody else. But since most countries do use this metric system, scientists around the world use this system to be able to interpret one another's measurements more easily. So I'm going to go ahead and star that. Now this SI system is built upon 7 metric units, and we call these base units. And it's because they build the foundation of what everything else comes from. A couple examples of some base units are length and mass. Length is defined as the straight line distance between 2 points, and usually it is given the unit meter, abbreviated with a lowercase m. Mass is defined as the quantity of matter in an object or sample, and the unit that it gets is kilogram, which is abbreviated kg. Here is a list of the 7 metric base units that make up our SI system. The first 4 I'm going to go ahead and star because these ones you should be familiar with by the time your test comes around. I will ask them on your test or quiz. First one is length, meters. Notice it's a lowercase m. Mass is kilogram, abbreviated kg. Temperature, which we're going to learn about in the next lesson, is Kelvin, which is a capital K. And then time, which is second, which is an S, or you can say an SEC, second. Those are the 4 you're going to be familiar with. If you decide to take chemistry, you'll learn about the mole and ampere and candela. These are usually talked about in a physics class. Other units do exist, and these additional units are called derived units. The reason they are called derived units is because they come from base units. Or your book says they are combinations of 2 or more base units together. 2 common ones that you're going to hear about is volume and density. Volume is how much space does an object take up, while density is the ratio of the mass to its volume. So density's equation is mass divided by volume. Here is common base units or derived units that come from these base units we learned about in a couple slides ago. For example, area is a derived unit of length times length. That's how I got my meter squared. Volume is a derived unit, and it comes from length times length times length to get my meters cubed. Density involves the base unit for mass and the base unit for length. Pressure, which we'll talk about when we get to the gases, our unit is Pascal, so it comes from mass, length, but also time. If you get down to frequency and electric charge, those also come from those base units that we mentioned. So to arrive the SI unit for density, you can take the base unit for mass and the derived unit of volume, divide those 2, and that's usually how we get to the units that we use. Kilograms is for mass, cubic meters is for volume. So when we divide those, mass divided by volume, we see this kilograms and meters cubed. Now, a bar of solid has more mass per unit volume than a feather, so we usually say that it has greater density. One thing that I would like you guys to write down is water's density equals 1 gram per milliliter or 1 gram per centimeter cubed. Please write that down in your notes. The next thing that we're going to hit on is metric prefixes. Now, a metric unit is not always a convenient one to use because maybe the object is very small or very large. So we add prefixes to the beginning of a word to indicate how many times we multiply or divide that base unit. So prefixes mean in front of the word. You have actually already seen one of these prefixes, and that is kilo. Remember kilogram? Kilo is going to be our prefix. Gram is actually our base unit. Other common ones that you might see is centa, if you've heard of centimeter. So centimeter. Centi is your prefix. Meter is an M, cm. Millimeter, that's another one. So millimeter, we got milli is an M, meter is an M, so you see an mm. Please note that prefixes, they have to have more than one letter to be a prefix. These always have to be combined with something. So this is something that I put on your guys' homework. You're going to see it. This is a metric conversion chart of some common prefixes. First, let's talk about the basic unit. The basic unit is a single letter by itself. So some common basic units are G, which equals gram, liter, which is a capital L. You might have even heard of meter, which is a unit for length. So all of these are common base units. Notice the letters by itself. From there, we have prefixes. So kilo is going to be abbreviated a lowercase k. Examples of this is things like a kilometer or a kilogram or say a kiloliter. Oh, also another one to add down here is second. So you can even say a kilosecond. Notice it all starts with K and then we match it with the base unit. Hecto's prefix is H, and this can be abbreviated like hectosecond, hectometer, even hectogram. So notice the letter goes over with the base. If we look at deca is abbreviated DA. So this one might be decaliter. So decaliter, maybe decameter. Deci is abbreviated with a D. So here you might see decasecond, deciliter, decimeter. Centi is with a C. So maybe centimeter, centiliter, centisecond. And then milli is an M. So millimeter, notice there's two M's. That's different than an M by itself. Millisecond, milliliter, milligram. The way this works is we're going to find out where we're starting and where we're trying to get to and count how many places we're going to move our decimal and which direction. So here you're starting with kilogram. So you're going to start here with the kilo. And then you're going to try to get to gram, and notice gram is a base unit. So you'll know you'll move 1, 2, 3 spots to the right. That tells me your decimal is going to move 1, 2, 3 spots as well. So 1, 5, and then we fill 0. My decimal is now there. On this one, for example, centimeter. We're starting over here in centa, and we're trying to get to millimeter. So notice we're going to move to the right, and it tells us to move to the right one time. So I'm moving to the right. So 9, 2, 4, my new decimal goes there. And last one, centiliter to kiloliter. So here, if I'm at centa and I want to go to kilo, notice I'm going backwards. I'm going to the left now. And let's count. 1, 2, 3, 4, 5 spots to the left. So if my decimal's here, 1, 2, 3, 4, 5 spots to the left. My new decimal, 45500. So for example, the time it takes for a computer hard drive to read or write data is in the range of thousandths of a second, such as 0.009 seconds. We can actually use the prefix milli to rewrite that number as 9 milliseconds. We can also use these to make the unit larger. For example, if a distance is 12,000 meters, I can write it as 12 kilometers, and it means the same thing. Lastly, metric prefixes can be used for non-metric units as well. Especially if you work with computers or play games, you've probably heard of a gigabyte or a terabyte. Giga and tera are just prefixes. If you work with a camera, megapixels is just a prefix put on the base unit of pixel. And that's the end of today's lesson. Let me know if you have any questions, and I hope you guys have a great day.